Alright, hello everybody. We're back in the familiar format of on the computer screen. I know you guys missed the board already. I do too. Um, so, for problem example 3 in 7.5, it says you design a football play in which a player runs down the field, makes a 90-degree turn, and runs to the corner of the end zone. Your friend runs the play as shown. Did your friend make a 90-degree turn? Each unit of the grid represents 10 feet. So, what we know, if he did make a 90-degree turn, that would make this triangle a right triangle. One of the characteristics of a right triangle is that it has a right angle. So if the triangle has a right angle, then it's a right triangle. And what we've been dealing with to figure out whether triangles are right triangles or not is the converse of the Pythagorean theorem, a key idea at the beginning of the section, at the beginning of section 7.5. It's like what we did for examples 1. For example 1, A and B, where we checked the side lengths, and if A squared plus B squared equaled C squared, then we knew we had a right triangle. So, we don't know the exact distances here. We don't know the distance for D1, we don't know the distance for D2, or the distance for D3. So, in order to tell whether this guy made a 90-degree turn, to tell whether it's a right triangle, we need to find the distance of all three of these sides. And then remember, what did we use to find the distance between 2 points? It is the last key idea we just talked about in example 2. It's the distance formula. So you use the distance formula to find the distances of these sides to find how long they are. Alright, so the first thing we do is write in the distance formula. So let's do side D1 first. So D1, we use our ordered pairs 60, 50, and 30, 20. And then we plug them into the equation. We substitute them in. We put the so it treated this as the second ordered pair. This is the first ordered pair, this is the second ordered pair. So it made 60x2, and then it made 30x1, and then it made 50y2 and 20y1. So it set them into D1 like this, like so. And then it simply subtracted 30 from 60 and squared it, and did the same for 50 minus 20. They subtracted, then squared. So once you get to this point, 30 squared plus 30 squared, you get the square root of 1800. And distance 1 comes out to be the square root of 1800 feet. We follow the same process for D2 here. We use our two ordered pairs, so D2 is this one. It treated this pair down here, 80, negative 30, as the second pair, the second coordinate pair, and this is the first pair. We follow the same process to get the square root of 5,000 feet. And then we do the same thing for D3. Okay? At this point, what we need to do, once we've got the distances of the three sides, we do what we did in example 1. We use the Pythagorean theorem, a squared plus b squared equals c squared. And then the converse of the Pythagorean tells us that if a squared plus b squared does equal c squared, then the triangle is a right triangle. And that means that that teammate did make a 90-degree turn. So, like I just said, we use the converse of the Pythagorean theorem. And since the square root of 6800 is bigger than these two numbers, that is our hypotenuse. So we put that in for C. So we take the square root of 1800 squared plus the square root of 5000 squared, and check and see if it's equal to the square root of 6800 squared. And remember, what did I say about squaring and square rooting? They undo each other. So simply, the next step, it'll just be 1800 plus 5000 equals 6800. And then we need to make sure that those do equal each other, which many of you probably already see they do. Because 1800 plus 5000 6800. So both sides equal each other, which means that it is a right triangle, and our player did make a 90-degree turn on the field. There's a lot of steps to these problems, guys, so you need to make sure to go slowly. Don't rush through it, because if you rush through it, you're going to make a small mistake here and a small mistake there, and then they just really build up on each other. So take your time with these like this kind of problem. Okay? If you feel comfortable with this problem, make sure to do the on your owns. Otherwise, try watching the video again. Um, and then I hope you guys have a nice night. I mean, I'll see you tomorrow in class, alright? Have a nice night. Thank you.